So last week we finished the theory part of this topic, center of pressure, and from today inshallah we are going to start its numericals. So if you have any question or query regarding this theory about center of pressure, how can we calculate the resultant force and the point of center of pressure. So who will tell us that what is the difference between this center of pressure and center of gravity? जी बच्चे. So do you know how we can calculate the force? So this is the formula for force, which is F is equal to gamma HCA. And what is HC here?
Vertical depth of the centroid.
Vertical depth of centroid. Very good. Of body or of water surface? जी बच्चे बताएं. Say if we have a water surface here and our body is located here, and this is the point of centroid of the body, then what would be the word HC in this figure? Will it be from here to here, or would it be from here to here? Say this is 1 or 2. So will it be 1 or 2? Yes, please. Okay, if you recall this figure, where is HC here? I need your participation, please. Say if we have a body and its centroid is point here, the HC would be from the water top surface. Okay, just remember this point. That HC is the water depth from the top water surface to the centroid of the body. Okay, and there's no point of center of pressure as long as we are calculating the force. Okay, so from the formula of 3.16, you can clearly see that in order to find the force, uh, we need to multiply the pressure gamma h acting at the central point with the area. Okay, so there is no point of pressure prism concept involved in this as long as we are going to find the force. Okay, so just remember this. And the center of pressure, which is P here, is the point about which the resultant of pressure or this force will act. And this is a point we call it as you can say the center of gravity of pressure prism. Say if we have a exact triangular distribution diagram, then the point P would be, it would be 2 by 3 from the top and 1 by 3 from the bottom. Okay, so we can easily calculate the centroid point of this triangular shape. However, if we have an irregular pressure distribution diagram and we do not know the exact formula for the centroid point, then we have to follow the formula which is yp is equal to yc plus ic over yca. Okay, and in this point, actually, yc is the distance of, from here you can see the distance of centroid of body. Okay, what is yc? The distance of centroid of body. Okay, and I say again moment of inertia about the centroidal axis. So using this formula, we have actually transformed the yp by using parallel axis theorem in terms of yc. Okay, and because it's difficult to find out the centroidal uh, distance of pressure prism, so therefore we have just transformed this yp into yc by parallel axis theorem, and for any body we can find the centroidal point, whether it be moment of inertia or it be the centroidal distance. Okay, so just you need to remember these two formulas, which is 3.18 yp is equal to yc plus ic over yca, and the other one is f is equal to gamma hca. Okay,
Yes, sir.
so we will solve this problem. Determine the force that the water pressure exerts on the inclined side. Okay, we have to find the force on the inclined side plate a b d e. Here is a b d and e of the storage tank, and find its location of measured its location measured from the plane AB. Okay, from here we need to find, say, yp. So how can we solve this problem?
पीछे वाले दोनों फार्मूला यूज होंगे.
Okay, very good. So
सर इसका पहले सेंट्रोइड फाइंड करेंगे.
सेंट्रॉइड किसका फाइंड करेंगे?
ये प्लेट का जिसपे फोर्स हमने मालूम करनी.
ठीक है, तो सेंट्रॉइड क्या होगा? yc क्या होगा?
x/2 y/2 सर.
सर वाई सी गिवन है.
yc is given, or even you can find out. I mean, if you have simple rectangle plate of dimension 6 feet by, you can say, 3 feet, so yc would be 3 feet from the top, isn't it? So yc would be 3 feet. So can you find hc? But if you see the formula, because we are going to find the force, fr is equal to gamma hca. So how can you find hc from yc?
सर फार्मूला इज एच सी इज इक्वल्स टू वाई सी साइन थीटा.
Okay, very good. Can you transform, uh, I mean, if you have all the dimensions given to you, can you find hc if this is 6 foot and this is 5 foot?
यस सर, साइन थीटा विल बी इक्वल्स टू 5/6, सो 3 मल्टीप्लाई बाय 5/6 आ जाएगा.
3 multiplied by 5 by 6. So hc would be 2.5 feet. Okay, so from this you can easily find fr. You have the value of gamma, which is 62.4 pounds per foot cube, and okay, I will write fr would be equal to 62.4 times HC, which is 2.5 feet, and times area. What
area.
area क्या होगा?
Sir, 6 multiplied by 3 length into width.
Very good.
18 हो जाएगा सर.
3 multiplied by 6 would be the area. Okay, and the answer is, it's all written on the slide as well, 2808 pounds. Okay, I'm not writing it here. So first part
Okay, sir.
is clear now, and
Yes, sir.
next is we need to find the center of pressure, or you can say the location of center of pressure, which is YP, and it's written. Just look at the figure YP. So we do not know YP. If we want to use the formula, YP is equal to YC plus
Our
IC, or I am writing it in terms of X. Okay, IC over YCA. So the only thing left in this formula is basically the Ix dash. Okay, so for the formula of Ix is 1 by 12. What is the moment of inertia of rectangle? Who will tell? What is the formula of moment of inertia for a rectangle?
no idea, sir.
Have you studied BA cube by 12? इंजीनियर मैकेनिक्स में नहीं पढ़ा?
Yes, sir. Yes, sir.
Yes, sir.
Okay, so it would be BA cube by 12. Okay, so this is for moment of inertia of rectangle. So what is the value of B in this figure and A?
Sir, B will be equals to 3 and A will be equals to 5 or,
5?
or 6, sir, I guess 6.
6. Very good. So B would be equal to 3 and A would be equal to 6 feet. Why have you not considered A equal to 3? जी बच्चे.
सर बी बेस है तो बेस 3 ही है, यहाँ पे गिवन भी है वैसे भी.
ठीक हो गया. X, because we are actually taking moment of inertia about X. So just like if this is X dimension, then this would be the base. Okay, so here in this figure you can see that the perpendicular dimension against X is 6 feet. So we will take the cube of 6. So if I say that take the moment of inertia in terms of Y axis, then you will take cube of 3 feet instead of 6 feet. Okay, so from this formula you can simply find out Ix, and by putting Ix in the formula of Yp, you can simply find the distance of center pressure, which would be 4 feet from the top. Okay, it would be 4 feet from the top. Any question?
सर ये ए बी वाला बता दे, ए किसको रखना है, बी किसको.
Okay. Just wait a minute. So it's written, say if we have a figure, this is say X and this is Y. Okay, say this is 3 feet and this is 6 feet. If I asked find the moment of inertia about x-axis, okay, say Ix would be up rotation about x-axis would be in this phase, okay. So you will take cube of 6 feet in terms of x-axis. So let's say 3 6 cube by 12. And if I say find the moment of inertia in terms of y-axis, so y-axis rotation would be in this phase. So therefore, the base would be 3 feet here. So we will take cube of 3 feet. Okay, 6, 3 feet cube by 12. So if you look at the figure of the problem, if I say find the moment of inertia in of x-axis, so you can easily sorry. Okay, now in this figure, x-axis is here. Say this is x-axis. So the base would be 6 feet. Okay, so we will take a cube of 6 feet. However, if I want to find the moment of inertia of y-axis, then we take cube of this side. समझ आ गया?
यस सर क्लियर हो गया.
Okay, thank you. So next problem, you can do it by yourself, very simple. Can you do it?
Why not, sir?
So we are going to find the resultant force and water pressure. Just 3 feet is the centroidal distance from top and 2 meter is the diameter. Okay, so you can find the area using the 2 meter, and HC is given to you as this is the vertical depth. So it's very simple. Okay. Next problem, the cubic tank shown in the figure is half full of water. Find, first of all, we need to find the pressure at the bottom of the tank at this point, pressure, and next is the force exerted by the fluids. Fluids means it includes both air and water on the tank wall. And third, C is the location of center of pressure on the wall. So on the left, on the right side, there is a pressure distribution diagram for both of the fluids. A is representing air and B is representing water. Okay. And B is water. So it's clear. I think it's there should be no confusion why the pressure distribution diagram of water is triangular. Okay. Whereas for air it is rectangle and the air is exerting pressure towards all sides, just like this one. And from this water body, obviously the air would exert pressure on this surface, and ultimately it will be transferred to the bottom as well. So therefore, air is exerting pressure to all of the sides of the container uniformly in all direction. Okay, and the pressure of the air by some gauge measurement, it is showing 8 kilopascal. So this is the pressure of air. So pressure which is exerted by air is 8 kilopascal. So can you solve it?
Yes sir.
सर
The
इसमें
solution of this
फोर्सेस
problem is
सर इसमें जो फोर्सेस हैं वो इंडिविजुअल तो नहीं करनी ना, वो पूरी एक जिस तरह ये टैंक है उसकी पूरी फाइंड करनी है ना.
पूरी find करनी है, but हाँ, obviously we will divide the total force in terms of air and water. So we will separately find the forces. against air and water, and at the end we will add both the forces. Okay, so
Okay,
we will move step by step. First of all, first thing is pressure at the bottom. कैसे फाइंड करेंगे प्रेशर एट द बॉटम?
सर हम प्रेशर हेड से भी फाइंड कर सकते हैं, पहले वो फॉर्मूला यूज करके।
ठीक हो गया. First of all, pressure, it's very simple. Pressure of air is already provided, which is 8, and pressure due to water at this point, P is equal to gamma H. Okay, and what would be the value of H here?
1 मीटर सर।
1 sir.
1 or 2?
1 sir.
Very good. So 9.81 times 1. So using this formula, we can find pressure at the bottom. So next things which is required to be solved is force exerted by fluids on the tank wall. Force. So we will separately find force. बच्चे अपना mic off करो यार, जिसका भी mic on. Okay. So force F is due to air and FB due to water. As a pressure exerted by air on the tank wall is already given, which is 8 kilopascal. So we will simply multiply this pressure times the area in order to find the pressure, in order to find the force due to air. Okay, so what would be the area while calculating force due to air?
2 मीटर स्क्वायर।
2 meter square. Okay, or it would be 2 times 2, 4. जी बच्चे,
Sir 2 times 2 होगा sir.
2 times 2 होगा. How?
सर बिकॉज एयर जो है वो वाटर पे भी तो प्रेशर एक्सर्ट कर रही है, तो जिसकी वजह से वो बॉटम पे भी जाएगा उसका प्रेशर।
Very good. So the total pressure which is exerted by air on its all four sides, so it would be 2 times 2 is equal to 4. Okay, so it is basically 2 times 2, 8 into 4. Okay, so now coming towards the water side, so you can see that the water, obviously water will exert pressure on this 1 meter depth, isn't it? So can you find force by water by simply using the formula F is equal to gamma HCA, and what would be the HC in this figure? HC इसमें क्या होगा? बोलो, कुछ तो बोले बच्चे, बेशक गलत बोलना.
सर वही
सर सेंटरॉइड का इसका जो एरिया होगा रेक्टेंगल का, तो वो b/2 होता है, तो वो 0.5 होगा।
वेरी गुड. सो HC मैंने आपको पहले बताया था कि HC में आपने कंफ्यूज नहीं होना प्रेशर डिस्ट्रीब्यूशन डायग्राम से. ठीक है, HC is related to this sides, as this is rectangle, exactly rectangle, so it would be say b/2. So what is the b/2? 1 meter, it would be 0.5. Okay, so HC would be 0.5, and the area, obviously the area for water is 2 times 1, so we will take the area 2 into 1. Okay,
यस सर।
so finally we will find the total force by summation of F of A plus F of B. So it's very simple. Okay, so the third part of this question is that we need to find the location of center of pressure. So center of pressure, as it is mentioned in this problem, that we need to find from the water top surface. Okay. So we are actually ignoring at the moment the top area, which is due to air. So as the center of pressure greatly depends upon the water surface. So therefore, if we want to find it from the top, then obviously we will add 1 plus this yp. Okay. So center of pressure from the water top surface, how can we find it? We can either use formula, or if we know the pressure distribution diagram, in this case it is exactly triangular, so we can use a formula for centroid of triangle as well in order to find yp. कोई बता सकते हैं yp हम कैसे फाइंड करेंगे?
सर वही फॉर्मूला लगा के वाई सी प्लस आई सी डिवाइडेड बाई वाई सी इंटू ए.
ठीक हो गया. और ऑल्टरनेटिवली कैन वी यूज or say 2 by 3 of 1. जी बच्चे, एक तो आपको मैंने बता दिया कि आप यू कैन यूज सिंपली फॉर्मूला. However, at this moment we also know the exact distribution of pressure, which is exactly triangle. Say this is P. So can you use 2 by 3 of 1?
Yes, sir.
यस सर हो सकता है इसका.
हो सकता है. ठीक है. So we can use either 2 by 3 of H of water, or we can also use this formula yc plus ic over yca. So in both the cases the answer would be same. Okay. So read this statement: the location of center of pressure of the component forces as distance yp below the top water surface are. So ypa in this case is 0. So ypb is 0.667. So in order to find the total ypa, so we can take the moment about the water top surface. So we have the total force F of P, just like take the moment about this point, force into distance. So F is the total force and this is the total Yp is equal to F of A, which is air, it would be equal to 0, and F of B would be just simply multiply this force 9.81 times 0.67, and when you solve it this you will get 0.1565 meter below the water top surface. Okay, any question? Any question?
नो सर.
Okay, so we will solve one last problem related to this curved surfaces. Okay, so the concept is the same as the previous one. However, in this problem we have oil instead of air, and also the shape of this storage tank is semicircle. Okay, at the bottom. So this is semicircle. So means we are going to use centroid formula or moment of inertia formula for semicircle. Okay. So the lower part of this container is filled with water. So the radius of that is 1 foot, and above that water we have, say, a rectangle surface which is of 1.5 feet. Okay. So two shapes. Okay, so this is one-dimensional figure, and this is, you can say, just to in order to make the concept. So we do not know that how it looks in three-dimensional. However, it is just a one two-dimensional shape. Say for oil, we have an area of 2 times 1.5 feet. Okay, so area of oil, and area of water we can find out pi r square. So r is 1. Okay, so now just observe the pressure distribution diagram for this particular case. So at the top we have oil, and oil is exerting pressure on a rectangular wall of 1.5 feet, and the pressure distribution diagram is triangular. Okay, and A is the pressure distribution diagram which the oil is exerting on the wall, on its wall, and D is the pressure distribution diagram which the water is exerting on the end wall. So who will tell what is the pressure distribution diagram which is represented by B here?
सर
As
ऑयल
as
एंड वाटर.
जी बच्चे बताएं.
सर ऑयल की जो प्रेशर एग्जर्ट कर रहा है वाटर पे.
Very good. So B is the pressure distribution diagram which an oil is exerting on water top surface, and it is, as it is a horizontal surface, so it is transmitting uniformly over the whole water surface. So that's why you can observe that the pressure distribution diagram of B is exactly rectangle or square, means it is not changing with the depth. Okay, so A is the pressure distribution diagram which oil is exerting on its wall. B is the pressure distribution diagram which oil is exerting on water top surface. Similarly, D is the pressure distribution diagram which the water is exerting on its end wall. So any question regarding these two figures? Any question?
नो सर.
Yes, sir.
Okay. So now we will find what is required in this question. First of all, we need to find the pressure at the bottom at this point, which would be the summation of pressure of oil and water. And second, we need to find the total force, and finally the depth of its center of pressure. Okay, so first part, pressure at the bottom is summation of pressure exerted by oil and pressure exerted by water. So gamma of oil, specific gravity is given. So can you find a specific gravity is equal to gamma of oil divided by gamma of water. So can you find gamma of oil? Yes, no?
Yes, sir.
Okay. So we can easily find gamma of oil by multiplying the specific gravity times the specific weight of water. And the height which is used in order to find the pressure in terms of oil would be 1.5 feet. Okay. Similarly, we can find the pressure of exerted by water. अब इसमें depth कितनी है? ये 1
1
feet. Okay. So 1 feet is the height of water in order to find the pressure exerted by water. So after that, we can simply add both these pressures in order to find the total pressure which is exerted at the bottom. Is it clear now?
Yes, sir.
Okay, next point is we need to find the total force exerted on end wall by the liquids. And it means that we need to find force due to oil, we need to find force due to water, and also we are going to find the force which the oil actually exerts on the water top surface. So F of A. So here it's written that the force acting, we can first read it. The force acting on the end consists of three components labeled as A, B, and D on the pressure distribution sketch. Note that the component B has a uniform pressure distribution. And what is the reason? I have already told you. Due to the oil A above which acts throughout the liquid below. As preliminary, we note for semicircular and area, say radius r, area for semicircle is pi r square by 2. 2 is for semicircle, pi r square is for area of circle, and if we divide it by 2, it becomes semicircle. And from appendix A, table A7, the centroid for semicircle is 4r over 3 pi. So you can simply relate this to any of the figure. You can simply go through the literature and you can simply find the centroid of any shape. So here, as the semicircle is provided, so the formula is 4r over 3 pi from the center of circle, and that is below the water top surface. Okay, so this is from this water top surface 4r over 3 pi. It would be different if we are going to find the semicircle from the bottom to top. Okay, so for component A, formula for force is F is equal to gamma HCA. So for component A, obviously we are going to use gamma of oil, and what would be the HC in terms of oil?
The centroid of rectangle 1.5 divided by 2, 0.75.
Very good. So 0.75 would be the HC below the free oil surface. Okay. And what would be the area of oil?
Sir, length into width, so 2 multiplied
2
by
times
1.5.
1.5. So 2 by 1.5, 2 times 1.5. So you can find the force due to oil A. Is it clear? So next component is B. So this is a bit tricky. B is basically the force which oil exerts on water surface. Okay, so we are going to find the pressure gamma HC of oil, and area we will use area of this water surface which is semicircle. ओके ये थोड़ा सा ट्रिकी है इसमें हम जो प्रेशर किसका एक्सर्ट हो रहा है वो ऑयल से हो रहा है तो वी विल यूज gamma, this is gamma of oil, and the height is basically 1.5 feet total. ठीक है जी. अब ये प्रेशर कहां पे एक्सर्ट हो रहा है? अगर मैं आपसे कहूं यहां पे प्रेशर निकालें P इज इक्वल टू gamma H, तो हाइट कौन सी यूज होती है?
सर ऑयल की जो पूरा टैंक है उसकी हाइट यूज करते हैं हम.
तो हाइट इज फॉर ऑयल इज 1.5 फीट. ओके, एंड गैमा ऑफ ऑयल. सो यहां तक क्लियर हो गया. हमें पता है फोर्स किसके इक्वल होती है? प्रेशर टाइम्स एरिया. सो प्रेशर ड्यू टू ऑयल एंड एरिया जिस पे वो अप्लाई हो रहा है. अब किस पे अप्लाई हो रहा है? वो वाटर का एरिया है. ठीक है जी. अब वो कैसे आएगा? पाई आर स्क्वायर बाय 2 विच इज फॉर सेमी सर्कल. एनी क्वेश्चन या ना समझ आई हो किसी को? Any question?
No, sir.
Okay, thank you. So last part for this force is F of D. अब F of D क्या है बेसिकली हमें पता है फोर्स जो डायरेक्ट हम निकालते हैं फोर्स F is equal to gamma HCA. अब gamma here it would be of water and HC is the centroid of semicircle which we have calculated as 0.424. Okay, gamma here just look at this gamma HCA. अब एरिया जो है वो सेम होगा वाटर का, ठीक है जी. So we can add all the three forces to get the total force. Any question? Any question
No.
regarding the forces? Okay, now if it's all clear, then we will move towards the center of pressure point. So just like we can find the just like we found centroid of semicircle by using the literature provided in different books, we can also find the moment of inertia I about the circle, which is pi d square by 128. Basically circle का क्या होता है semicircle? pi d 4/64 होता है. सर्कल का जो होता है मोमेंट ऑफ इनर्शिया क्या होता है? pi d 4/64. So if we want to find for semicircle, just divide it, multiply by 2 here. So it would be pi d 4/128. And d is 2 feet here as r is 1 feet. So this is for semicircle, okay? And by using parallel axis theorem, IC is equal to I plus AD square. Okay? ये पैरेलल एक्सिस मैंने आपको लास्ट टाइम कंसेप्ट दिया था. अगर किसी को कंसेप्ट नहीं क्लियर तो वो लास्ट रिकॉर्डिंग सुन सकते हैं जिसमें मैंने एक फिगर ड्रॉ करके इसका पूरा डिटेल बताया था कि पैरेलल एक्सिस थ्योरम से मोमेंट ऑफ इनर्शिया अबाउट any axis equal to moment of inertia about centroidal axis plus the product of area and perpendicular distance between the two axes. So we can find IC as I plus AD square. So A is for semicircles and D is again here the centroidal distance as we are finding IC. So YPA, it's very simple. We can use if you look at this figure. So as this is exactly triangle, so it would be 2 by 3 of this height, which is 1.5. And you can also find YPA by using formula as well. Okay. So YPA is simple. So YPB would be basically this is centroidal distance of semicircle, just like this one. As this is the centroidal distance of triangle, so 0.424 plus the as our YP distance is from the top, so we are actually adding 1.5 into this thing, 0.424. So it is basically the centroid of water wetted semicircular area from the uniform pressure on this due to the 1.5 feet of oil above water. And YPD would be YC plus IC or YCA and IC we have separately calculated from this one. So you can also find YPD. Okay, and obviously you will add 1.5 fit as your datum point is at the top. In terms of just you have to add 1.5 for YPB and YPD. And finally, you can just take the moment of say total force times YP and F, and this one is unknown. So can you find YP, last point? Any question?
सर
नो
हमने
सर।
सर ये आई सी जो है मोमेंट ऑफ इनर्शिया ऑफ सेंटरॉइड, इसको डायरेक्टली क्यों नहीं फाइंड किया, इसके साथ हमने ए डी स्क्वेयर क्यों ऐड किया?
बात हमने क्योंकि हमें जो सेंट्रॉइड है इस पॉइंट की बात कर रहे हैं।
यस सर।
देखो हमें बॉडी की शेप पता है ना अभी, और जबकि उसमें हमें प्रेशर डिस्ट्रीब्यूशन डायग्राम हमें नहीं पता। हमने यहाँ ट्रायंगल तो लिखी है लेकिन हमें एग्जैक्टली पता नहीं है इसकी शेप। तो हमने इसमें रिवर्स चले हैं कि सेंट्रॉइड जो है वो आई सी पे हमने फाइंड किया। आई सी अबाउट द सेंट्रॉइड डिस्टेंस विच इज 0.424 बिलो द सेंटर ऑफ सर्कल। तो हम इसलिए उसको हमने रिवर्स कन्वर्ट किया आई सी को आई की, क्योंकि हमें सर्कल का सेंटर पता है सेंट्रॉइड, तो हमने इसलिए उसको आई सी को ऐड किया।
ओके सर।
Okay, I is basically about center of semicircle. ठीक है?
यस सर।
Okay, so few exercise problems which you will solve it by yourself. It's very simple. हम just मैं इसको थोड़ा सा brief कर देता हूँ. For example, a circular area of diameter d is vertical and submerged in a liquid. For example, if this is a circle and is submerged from here, and diameter is again d, its upper edge is it's coinciding with the liquid surface. Derive an expression for the depth of its center of pressure. So you have to use simply formula of Yp is equal to Yc plus Ic over Yc. So what is the Yc of circle? It's d by 2 and Ic of circle is
और यार वो चार्जिंग करनी पड़ेगी, उसकी चार्जर लगाएगा साथ वो।
हाँ बस ठीक है, ये चार्जर पूरी होगी इसकी। ऐसे गंदी बातें करता है तू, दे दे उसको उठा के। मेरी क्लास हो रही है, मैं आगे दे उठा के।
वही मैं कह रहा हूँ ना, क्लास सुन रहे हैं, दबा बैठ जा।
बार-बार डिस्कनेक्ट हो रही है, बार-बार कनेक्ट करनी पड़ती है।
हाँ तो बल्कि वो
दानिश भाई आपका माइक ऑन है।
दबाओ तू, वो कर अपना, चल दिमाग नहीं खराब कर। हाँ
इसको समझाओ यार, थोड़ा सा क्लास के उसमें ख्याल किया करें। So I was just discussing this first exercise problem. So it's easy for the first one. We have done the first one. So next is if the triangle of height D, say we have a triangle of height D and base B, say just like this one. this is B and this is D, is vertical and submerged in a liquid with its base at the liquid surface, derive an expression for the depth of center of pressure. So how can you find YP?
सर वो फार्मूला ही यूज करेंगे बाय सी का
इसमें YC क्या होगा?
b/3
D/3, very good. So D/3 YC होगा और एरिया क्या होगा? BD divided by 2.
यस सर
What would be the IC? B, I think
क्यूब डिवाइडेड बाय 36
BD cube divided by 36 होगा, ठीक है जी. So here YC would be in for figure for 2, it would be D by 3 and IC would be BD cube by 36 and area would be BD divided by 2. Okay, so you can put all the values in the formula of YP and you can find YC. Okay, so third one is if a triangle height D and base B is vertical and submerged in a liquid with its vertex at the liquid surface. So it is the reverse of figure 2. Vertex is touching the what surface? Say this is B and this is D. D or H? Height is it's representing with H here. Okay. So now YC would be क्या होगा YC for problem 3 for this figure? क्या होगा YC?
सर b/3
No, B/3 तो यहाँ से होगा ना. It could be 2/3 B, 2/3 of D you can say or H, ठीक है. टॉप से देखना है ना आपने. So यहाँ से 2/3 है, यहाँ से 1/3 है. So 2/3 आपने यूज करना है. बाकी चीजें क्लियर है आपको. मोमेंट ऑफ इनर्शिया I BD cube by 1236 होगा और एरिया would be D by 2. Any question in these three small problems?
नो सर
Okay, so these two problems we are going to solve it by yourself. It's very simple. We have done I mean more complex problem than this, so it's a very simple problem. Only one liquid and you have to find F and Y. And this one again, two liquids, one is oil and the bottom liquid is water, and it's I think you can do it easily. कर सकते हैं.
यस सर हो जाएगा
जी सर करेंगे ट्राई इंशाल्लाह.
हो जाएगा इंशाल्लाह. Okay, so the next topic is force on a curved surface. So this is the last topic of pressure fluid statics. Inshallah, we will finish it hopefully within few minutes. Force on a curved surface. So the first part of this lecture was force on a plane area. Then the second part was related to force on a sloping area. Now this one is force on a curved surface, curved and submerged surface basically. So you see this figure A on a curved surface such as MN in figure A, the force on various elementary areas that make up the curved surface are different in direction and magnitude. So algebraic summation is impossible. Obviously, And according to the principle, it says that the force acts perpendicular to the curve direction. Okay, so it is different in direction and also in magnitude as well. So it's impossible to add all the forces in order to find the resultant forces. So therefore, what would be the procedure? जो हमने पीछे कंसेप्ट पढ़ा वो बेसिकली अप्लाई होता है फॉर एनी प्लेन एरिया. ठीक है जी, जो रिजल्टेंट भी हम निकाल लेते वो किसी प्लेन एरिया के था, आइदर इट इज inclined or straight or provided for some angle. Okay, so but for non-plane area, we will find the components of these forces, say Fx and Fy, and after that, once we have Fx, then we can find the resultant forces using this formula. ठीक है जी. So what is the method of finding the forces on a curved surface, or it's basically finding Fx and Fy. Say we have a curved surface as shown in this figure. If a submerged surface is curved, then the pressure acting on the surface will change not only its magnitude but also its direction, since it must always act normal to the surface. For this case, it is best to determine the horizontal and vertical components of resultant force caused by the pressure and then use vector addition to find the resultant. Okay. हमने क्या करना है? First of all, we need to find the amount of curved surface. For example, if in this figure we have three different surfaces, two plane surfaces. So 1 and 2 are plane surface, which is exactly vertical and horizontal, and the third one is the curved surface. So the method in order to find the resultant force for plane 1 and 2 we already have discussed. So now for plane 3, which is curved surface, first of all we need to identify its boundaries. I mean, to which extent this curved surface is projecting. And after that, just take the projection of curved surface in horizontal and rectangle direction. For example, if we have a curved surface like this, so this is its vertical projection, means the extent of vertical limits, and this is its horizontal projection. प्रोजेक्शन का पता है सबको? ड्राइंग में आप सबने पढ़ा होगा. Do you know the concept of projections? Are you listening to me?
Yes, sir.
What do you understand by projection?
सर एक इमेज टाइप सी बन जाती है 2D में, उसे प्रोजेक्शन कहते हैं.
ठीक है, ड्राइंग पढ़ी है ना आपने अभी?
यस सर.
तो उसमें प्रॉब्ली पढ़े होंगे आपने हॉरिजॉन्टल प्रोजेक्शंस वगैरह कंसेप्ट.
यस सर.
Just like this one, if this is a curved surface, then we have to find the resultant pressure loading on vertical projected area and uh, the say weight of volume of liquid above that plate. इससे पढ़ते हैं, यहाँ से समझ आ जाएगा. Say we have this curved area and this is its horizontal projection having dimension A and vertical projection having dimension B. So leave this curved surface and just draw its projection. So if this is the total height, so can you find f of x in terms of height h? Just like we we did previously in the previous problems. Obviously, there would be a pressure distribution diagram, as the greater the height, greater would be the pressure. So if this projection is exactly on at the top surface, then the pressure distribution would be rectangle triangle. However, as this projection is I mean is far uh, below than the top surface, so therefore its pressure distribution diagram would be some kind of a parallelogram. वर्टिकल प्रोजेक्शन की किसी को ना समझ आई हो? So if we are able to find f of x, then it would be equal to f of h. Here you can see that if just look at the free body diagram of enclosed liquid block, here f of h is equal to f of vertical force. Okay, similarly, if we look at the horizontal projection, so the pressure distribution diagram is exactly rectangle, as the horizontal pressure is uniformly distributed at its top surface. So f of y we can simply find uh, which is the force exerted by on this length. Okay. However, there's another force which is acting in vertical direction, which is the weight of liquid which is enclosed in between horizontal and vertical projection. So we have to add both vertical projection, vertical force F of y plus weight of water enclosed within this liquid block. बच्चे अपने mic off रखो. So weight plus F of y. So the total summation will give us the vertical force. Okay. So and once we have f of h and f of y, we can find the resultant force f of r. So horizontal force component on a curved surface is equal to f of x, whereas the vertical force component on a curved surface, we have f of y plus w. Any question in this slide?
No, sir.
Any question? Okay. So just you can also another figure how to understand about the vertical and horizontal projection. So f of v in this area would ah would be this area. Okay, and for finding f of h, area would be this area. Pressure times the area. Okay. So if say we have a very heavy liquid enclosed within these projections, then definitely we have to consider the weight of that liquid. In this case, say if we have a gas, then obviously the weight of a gas is negligible. So we can simply for finding the vertical force, we can ignore the weight of gas. Okay, so this is the same thing. I'm just omitting these slides. In fact, passing horizontal force on curved surface, vertical force on curved surface. मैंने आपको बता दिया इसमें इसका concept क्या है. So last problem, the sea wall in this figure, it's a curved surface wall, and if you look at back, I mean it's a continuous wall. A sea wall is 2.39 A in the form of semi-parabola. So this is the shape of this sea wall. Determine the resultant force acting on 1 meter of its length. So we have to consider say 1 meter its dimension, perpendicular dimension, and we have to find the force, resultant force for this 1 meter. And where does this force act on the wall? Obviously we have to find the center of pressure as well. taking density of water for sea water as 1050 kilogram per meter cube. So we have to divide it into its two projections. Say one is the vertical projection and the other is the horizontal projection. So this is the free body diagram for finding horizontal and vertical forces. So horizontal force component कौन कौन से होंगे? F of x, अब आपको पता है f of x आपने कैसे फाइंड करना है? गैमा
एफ ऑफ एच के
HCA यही है, यही है ना जी?
यस सर
ओके, सो गैमा की वैल्यू आपके पास आ गई 1050, ठीक है? ये बेसिकली, और HC क्या होगा?
8 सर
है HC क्या होगा?
सर 2/3 into 8
नहीं आपने हमने तो देखो ये स्ट्रेट वॉल है ना, हमने प्रेशर डिस्ट्रीब्यूशन डायग्राम हम फोर्स निकालते हुए फाइंड नहीं करते हैं, मैंने आपको पहले ही बताया था। तो HC वुड बी 8/2 and gamma is basically, it's not, gamma is here, density into G, gamma is equal to rho G, ठीक है जी? Okay, so gamma and HC area, what is area here? एरिया क्या होगा? 1 times this, यही होगा एरिया, 8 into 1, so this is area, this is HC, so यही तीनों चीजें चाहिए आपको। F of x equal to gamma HC times A, so you can find 329.62 kilonewton. Okay, so next is finding the center, or you can say center of pressure, YC. तो एज दिस इज, हमने सब प्रोजेक्शन को भी देखना है, ठीक है? प्रोजेक्शन आप देखें, ये ट्रायंगल है और टॉप से ट्रायंगल अगेन इट इज 2/3 of 8, जस्ट लाइक हमने प्रीवियसली इसको सॉल्व किया। सो एफ ऑफ एक्स इज वेरी सिंपल। एनी क्वेश्चन इन फाइंडिंग एफ ऑफ एक्स?
सर ये हमने लेंथ 1 क्यों लिया है?
बच्चे उसने उसने कहा है कि हम, मैंने आपको पहले बताया था, चलो मैं इसको डिस्कार्ड करता हूँ। He actually asked determine, अब ये पैराबोला, एक समंदर की वॉल अगर यूं चल रही है, ठीक है, इसकी क्रॉस सेक्शन इस तरह है, लेकिन ये लेंथ, वॉल कॉन्टिन्यू है ना पीछे,
यस
ठीक है?
सर।
अब उसने कहा डिटरमिन द रिजल्टेंट फोर्स एक्टिंग ऑन 1 मीटर ऑफ इट्स लेंथ। अब ये लेंथ हमने इतने, यानी कि यूनिट स्टेप में हमने फाइंड करना है 1 मीटर।
ओके सर।
ठीक हो गया? इनके अगर ये मैं इस तरह देखूं तो ये 1 मीटर है और ये 8 मीटर है। हमने यानी कि 8x1 आप इसका एरिया है बेसिकली, जो हमने प्रोजेक्शन देखी है, ये चीज आप देख रहे हैं। यानी कि अगर बैक साइड से देखें तो ये 8 है उस फिगर में और ये 1 है, ठीक है।
ओके सर, ओके।
So 8 times 1 is the area. So next finding f of y. Again f of y is uh, gamma HCA. So the vertical force is equivalent to the weight of water contained within the volume of x parabolic segment. From the inside back cover, the area of this segment, area of ABC. What is A here is A, B, C. So we have just, अगर हमने लिटरेचर को देखा तो इस पैराबोला की शेप का एरिया जो है वो 1/3 ऑफ बी ए है। ओके, इज इट क्लियर हाउ टू फाइंड द एरिया ऑफ ए बी सी? बच्चे बोलो।
सर ये
यस सर।
पैराबोला का फॉर्मूला है।
जी ये आई मीन एक्स पैराबोलिक सेगमेंट, ये इस शेप कोई शेप आर्क टाइप शेप हो तो उसका ये फार्मूला होता है 1/3 ऑफ बी ए। ओके, सो हेयर फोर्स हमने हमने क्या कहा, इस वर्टिकल फोर्स जो एक्ट कर रही है, एक तो टॉप से अगर कोई फोर्स है, जब हमने इसमें देखा अगर प्रोजेक्शन इसके हम देखें, ये शेप अगर हम देखें, अब इस केस में डेफिनेटली जो फोर्स है वो एफ वाई प्लस डब्ल्यू है, वर्टिकल फोर्स। एफ वाई कौन सी फोर्स है? जो इस ये सारा लिक्विड यहाँ पे एक्ट फोर्स कर रहा है। और डब्ल्यू कौन सी फोर्स है? जो इनक्लोज्ड वॉल्यूम नीचे एक्ट कर रहा है इस केस में। However, हमारे इस केस में this wall is not submerged. Okay, so जो टॉप प्रोजेक्शन पे इसके फोर्स लग रही है वो एयर का प्रेशर है मैक्सिमम, which is say 0. So the only vertical force F of V in this is basically weight. And weight कौन सा weight? Which this semi-parabolic fluid or water is exerting in downward direction. ठीक है जी, that's why we have only used this weight force. अब वेट किसके इक्वल होता है? स्पेसिफिक वेट, gamma is equal to weight per unit volume, and weight is basically gamma into volume, यही होता है। और gamma is equal to rho g, or and volume is area times 1, because we are actually finding for 1 meter. So this is gamma g, which is rho, and this is volume. And how to find the area of this uh, parabolic segment? It is basically 1/3 of BA. So that's how we can find W. So this force acts throughout the centroid of volume area that is formed inside. अब similarly हम इसका centroidal distance भी इसी जहाँ से हमने एरिया फाइंड किया वहां से हम सेंट्रॉइड का फॉर्मूला भी फाइंड कर सकते हैं, दैट इज फॉर सेमी पैराबोलिक प्रोफाइल विच इज 3/4 ऑफ 2। अब 2 कौन सा एरिया है इसमें? अगर इसको यहाँ से जो बॉटम वेट था बेसिकली, दैट इज बेसिकली 2। ओके, सो ये कुछ हमारी जो प्रोफाइल है वो इस तरह, शेप इस तरह की वाटर बॉडी की। तो ये जो डेप्थ विड्थ है 2, सो इस पॉइंट से यहां तक का सेंट्रोइडल डिस्टेंस बेसिकली इट इज 3/4 of this 2 dimension, which is 1.5. Okay, so for finding f of r, you just simply add both these forces of f of x and f of y. Any question?
सर ये जो
Any
एक्स
question?
बार है ये फॉर्मूला है, स्पेसिफिक फॉर्मूला होता है सेंटरॉइड का, ये जो
जी जी
पैराबोला है इसका?
जी जी, ये शेप का फार्मूला है, जस्ट लाइक हमने यहाँ पे देखा ये 2/3। अब ये y बार ट्राइंगल की निकालते हैं तो वो क्या होती है, 2/3 ऑफ हाइट, यही होती है ना। अब ये
यस
भी
सर।
वही, यूजिंग द टेबल ऑन द इनसाइड बैक फॉर अ ट्राइंगल from the surface of water, the component is 2/3. Similarly, for parabolic segment, centroidal distance is 3/4 of this. ये distance है, ठीक है। Obviously, vertical distance में ये different होगा, ठीक है।
सर ये जो 2 गिवन है ये एफ ऑफ वाई के रिस्पेक्टिव से हाइट बनती है?
नहीं नहीं, 2 जो है वो बॉटम डेप्थ है इसकी। ये जो एक सेकंड, इसमें नजर नहीं आ रहा, अब देखें, अब नजर आ रहा है 2।
यस सर।
2 बेसिकली ये वाटर टॉप सरफेस की जो फिगर आपकी बन रही है, उसका जो परपेंडिकुलर है वो 2 मीटर्स है, ये गिवन है,
ओके सर, ठीक है।
ठीक
सही
है।
है।
एनी क्वेश्चन? तो दिस लेक्चर इज फिनिश्ड नाउ। सो हमारे लेक्चर
एक्सक्यूज मी
खत्म।
सर।
जी बच्चे,
सर हमारे मिड्स ऑनलाइन होंगे या फिजिकल होंगे?
फिजिकल होंगे यार, ऑनलाइन क्यों होंगे? ये तो आज क्लास आपकी ऑनलाइन हुई है क्योंकि जो रूट्स नहीं आए, अदरवाइज तो आपके ऑनलाइन ही होंगे, सॉरी फिजिकल ही होंगे। क्लासेस आज की आपकी क्लास फिजिकल ही होनी थी, लेकिन ये आज जो क्योंकि रूट्स नहीं चले तो इस वजह से ऑनलाइन ली है क्लास। नेक्स्ट वीक अगर तो ये अल्लाह करे हालात ठीक हो जाते हैं तो आपकी फिजिकल